Friends, welcome to my channel. Dhanesh here.
Activation function decides whether a neuron should be activated or not by calculating weighted sum and further adding bias with it. The purpose of the activation function is to introduce nonlinearity into the output of a neuron. We know neural network has neurons that work in correspondence of weight, bias and their respective activation function. In a neural network, we would update the weights and biases of the neuron on the basis of the error at the output. This process is known as backpropagation. Activation function make the backpropagation possible since the gradients are supplied along with the error to update the weights and biases. A neural network without an activation function is essentially just a linear regression model. The activation function does the nonlinear transformation to the input, making it capable to learn and perform more complex tasks. See, these are the limitations of sigmoid and tanh activation function. Vanishing gradient, outputs not zero centered, computationally expensive. The Relu is the most used activation function in the world right now, since it is used in almost all the convolutional neural networks or deep learning, and the function returns 0 if it receives any negative input, but for any positive value x, it returns the value back. It's surprising that such a simple function can allow your model to account for non-linearities and interactions so well. But the ReLU function works great in most applications and it is very widely used as a result. The main advantage of using the ReLU function over other activation functions is that it does not activate all the neurons at the same time. This means that the neurons will only be deactivated if the output of the linear transformation is less than 0. For the negative input values, the result is 0. That means the neurons does not get activated. Since only a certain number of neurons are activated, the ReLU function is far more computationally efficient when compared to the sigmoid and tanh function. If you look at the negative side of the graph, you will notice that the gradient value is 0. Due to this reason, during the backpropagation process, the weights and biases for some neurons are not updated. This can create dead neurons which never get activated. This is taken care by the leaky ReLU function. Next, we will discuss about the advantages of ReLU. It avoids and rectifies vanishing gradient problem. ReLU is less computationally expensive than tanh and sigmoid because it involves simpler mathematical operations. Disadvantages of ReLU. One of its limitation is that it should only be used within hidden layers of a neural network model. Some gradients can be fragile during training and can die. It can cause a weight update which will make it never activate on any data point again, simply saying that Relu could result in dead neurons. In other words, for activations in the region x less than 0 of Relu, gradient will be 0, because of which the weights will not get adjusted during descent. That means those neurons which go into that state will stop responding to variations in error input. This is called dying Relu problem. The range of Relu is 0, infinity. This means it can blow up the activation.
Thanks for watching. Please like, share and subscribe. Thanks a lot.